What is solar energy? Solar energy is radiant light and heat from the sun that is harnessed using technologies such as solar heating, solar photovoltaics, solar thermal electricity, solar architecture, and artificial photosynthesis. Solar technologies can be characterized into two techniques depending on the way they capture, convert, and distribute solar energy. The techniques are passive solar and active solar.
Passive solar heating, as you may have guessed, is passive. In other words, it takes advantage of the existing heat generated by the sun to heat living spaces. And we have all witnessed passive solar heating when we climbed into a car on a sunny day. Rays from the sun entered the car windows and were absorbed by the car's seats, panels, and floor. And this heat got trapped in the car and warmed the interior. Passive solar heating is also what makes greenhouses effective at growing plants all year round. When the sun's rays penetrate the windows of the greenhouse, the items inside the greenhouse absorb and then release the heat, providing a nice environment for the plants to grow. Now, passive solar heating can be used in your home to cut your wintertime heating bill and improve comfort. But to fully take advantage of solar energy in this way, some planning is required. Because passive solar heating does not involve any mechanical devices, a home designed for passive solar heating will need to be positioned in a way that allows heat from the sun to enter in the winter and be rejected in the summer months. This positioning will vary by local climate conditions, but in the northern hemisphere, a good passive solar design uses south-facing windows to capture the sun's rays. In the winter, when the sun is positioned low in the sky, the southern-facing windows allow the sun's rays to enter through the windows and heat the home. In the summer months, when the sun is positioned high in the sky, a passive solar home will use a large overhang for shade. This prevents the sun's rays from entering the window, keeping the home cool. Active solar heating is a more involved process than passive solar heating. While passive solar heating employs methods to capture heat from the sun, it does nothing to actively enhance the process. In contrast, active solar heating uses mechanical and electrical equipment to enhance the conversion of solar energy to heat and electric power. While more involved, active solar systems can generate much more heat than a passive system. And for active solar heating, you will need a solar collector, which is a device used to absorb solar energy. Solar collectors can be simple designs, but you likely think of solar collectors as the solar panels found on rooftops of homes or other buildings. Solar panels are typically composed of photovoltaic cells, or solar cells, which are devices that directly convert light from the sun into electricity. Active solar collectors must utilize a substance to act as a conductor, so heat and electricity can be stored and transferred. This substance is typically air or a liquid. Active systems that use air are referred to as air collectors. Simply stated, this is a system that absorbs the energy through the air. Those systems that utilize a liquid as a conductor are called hydronic collectors. Hydronic systems will use water or a type of antifreeze to collect and transfer heat.
The total radiation energy received from the sun per unit time per unit area on a theoretical surface perpendicular to the sun ray at Earth's mean distance from the sun. It includes all types of solar radiation, not just the visible light. The rate at which energy reaches the Earth's surface from the sun usually taken to be 1366 watts per square meter. Next, solar energy lost by reflection and absorption. Once the sun's energy reaches the Earth, it is intercepted first by the atmosphere, and then a small part of the sun's energy is directly absorbed, particularly by certain gases such as ozone and water vapor. Some of the sun's energy is scattered and reflected back to the space by clouds and the Earth's surface. First, atmospheric absorption. In this process, sunlight is absorbed by an atmospheric particle, transferred into heat energy, and then converted into long-wave radiation emissions that come from the particle. This emission of radiation is in all directions, so a sizable proportion of this energy is lost to space. Next, atmospheric reflection. Reflection is a process where sunlight is redirected by 180 degrees after it strikes an atmospheric particle. This redirection causes a 100% loss of insolation. Most of the reflection in our atmosphere occurs in clouds, when light is intercepted by particles of liquid and frozen water. Latitude and tilt of the Earth's axis. Latitude is a measure of the distance you are located from the equator. It is commonly shown as an imaginary horizontal line that goes across the Earth on maps and is used along with longitude as a reference point to determine location. Latitude is an important factor in determining what type of climate a location will have. There are other factors that influence the weather on the Earth. One of these is the tilt of the Earth. The Earth's axis of rotation is tilted about 23.5 degrees compared to the plane of the Earth's orbit around the Sun. The Earth tilt also is responsible for the seasons in the world.
Assalamualaikum warahmatullahi wabarakatuh, and hi to Mrs. Azianty. My name is Aida Maisarah Binti Rahman, and today I'm going to talk about solar photovoltaic or solar PV. So, what is a solar PV? Basically, solar PV can convert photons or light into a direct current electricity by using a semiconductor that can exhibit the photovoltaic effect. And there are various semiconductor materials, but the most mainstream is crystalline silicon. But the other materials are being tested to increase its efficiency to convert the light into electricity, because solar cells can only display an efficiency about 20%, meaning they could only convert 20% of the incoming energy from sunlight into an electric current. However, within the hours of solar panel operation, the efficiency will drop to 18%. There's a lot of potential electricity being lost. So there is no wonder that scientists and engineers have been hunting down and make research trying to find the answers behind this mysterious loss in solar power for almost 40 years. By the way, solar panel can shift electricity generation from a big centralized facilities like a nuclear power plants, hydroelectric dams, wind farms, and so on, to a smaller decentralized production site like the roof of our house. And for your information, a number of solar cells connect to each other mounted in a frame called as a module, and each module is designed to generate approximately 30 volt DC. And to generate a large amount of electricity, the modules are grouped together to form an array, and this array are scattered in an open field to catch solar power as much as possible. And now we have to understand how PV cell works. PV cells use a photovoltaic effect to generate current. It's an effect where the photons of particular threshold frequency strikes a materials that can cause electrons to gain enough energy, such as silicon, to free from their atomic orbit. So solar cells contains two pieces of semiconductor, which is silicon, being sandwiched together, and one that is negatively charged, and on top of it is another one that is positively charged. And when the light hits the PV cell, it will collide with the negatively charged silicon, and the electron will fall and get attracted to the positively charged silicon. And as the electron travels from silicon to silicon, it will create a current we call as a direct current. And this type of electricity generally found in the battery. So we have two types of PV system that may be built in various configurations. The first one is the off-grid or the standalone system, and the second one is the grid tie. So what is the standalone system? Basically, standalone does not connect it to the power grid or any electricity. It only depends on its own, which is why we call it as a standalone system. Interesting, isn't it? And in standalone system, we have three configuration. The first one is without the battery, which is the direct array. And for the second one, which is the battery storage for the DC appliance. Usually, we use this in the small device system like calculator, car, parking meter, and whatnot. And last but not least is the battery storage for AC and DC appliance. Usually we use this for the larger system like building, refrigerator, dishwasher, and so on. And this battery will supply the DC power to the inverter to convert it into an AC power, which is then available for the appliance. Okay, Let's use an example, a home situation. Let's say that you have a solar PV, and when your solar PV generate more power than your appliances you're using, the excess can be diverted into the immersion or the heat pump to heat your water. So I think I will end this talk here. Thank you for watching.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone who is watching this video. My name is Haiqal bin Herman, and today I'm going to continue the subtopic for today's subject, which is the solar energy. So the next subtopic is about grid connected system. As you can see, what is actually a grid connected system? Well, it is the easy way to understand grid connected system is that it is a bunch of standalone system that is gathered into a one and connected into a one utility grid. Each of this solar PV standalone system is being standalone PV panel is put into a one giant utility grid. It's usually used for a heavy duty usage, for like example in the industry system or for a factory that use a lot of electricity and needs to use a lot of solar energy and solar panels. So they change into the grid connected system, which is more efficient for more power to be generated. So usually grid connected system has 5 main components. The first one is the solar panel itself. The second one is an inverter to invert the DC current into the AC current, since most industrial factories or stuff use an AC current. And then number 3 is a switchboard, which is to controls the grid itself. Number 4 is the electricity meter to control, to view all the electricity usage. And finally is number 5 is the main grid, which is the electricity main grid, which is where all the energy, the solar energy that has been absorbed and transferred into this grid. But the next subtopic is about solar thermal. As you know, solar thermal is the energy that harness the power of heat from the sunlight in order to generate thermal energy and also electrical energy for the use in the industry. As you can see, there are 3 main collectors of solar thermal, which is used in a very different situation. For the first one is the low temperature collectors, where usually the flat plates is used to heat up swimming pools and other small appliances. The next one is the medium temperature collectors, which is flat plates that is used for heating water and air for a big residential and commercial use. And then finally is for the industrial use, which is the high temperature collectors. This collector uses the mirrors and lamps to concentrate the light and the heat energy to produce more heat and more thermal energy, because they use a lot more generators and heat to for the industrial usage of electrical equipment. But the final subtopic is about solar thermal versus solar photovoltaic panels. So what are the difference? Well, solar thermal is basically the sunlight is used to generate heat instead of creating electricity, and it's also a bit more thicker than photovoltaic panels. And well, solar panel is usually used for the solar energy, which is sunlight, to produce electricity. So yeah, that's it.